Hello and welcome to my channel. Today here on the channel we have something a bit less vintage than usual. We have a GPU, it's a Zotac GTX 480. Well, I say a bit less vintage because this has been discontinued since 2018. This is a 2010 video card. Being the 480 used to be the top of the range of the 400 series. It's based on the Fermi architecture and I think it's like a 300 watts beast. It runs really hot, and again, it used to be the best in its range. Now this card works. We've seen it in a previous video I made where I was repairing this Asus motherboard, which you can see here and down below in the description. It works as it does output a picture, but it doesn't accept drivers. The Windows crashes when you install drivers. So I would say let's take a look and see what we can do for it. Okay, so the thing with this video card is that it works. Well, it works. It does work until you try and load drivers. At that point, you have a blue screen of death and the PC restarts. Let me see if I can show you what happens. This is an i7-940, and this is actually the motherboard which has always been with these video cards. So I was sent this motherboard and the video card because it was part of the same system. I have Windows 10 on a very slow SSD running on this, so let me power this up and I'll show you what's going on. Okay, here we are in Windows. Let me show you that basically the card now is working. This is, if I'm not mistaken, is 800 by 600, so it's very, very low resolution. And the card is now running with the Microsoft Basic Display Adapter. Now, being this discontinued card, nVidia released the last available version for these drivers in 2018. So 391.35 is the latest version available on the nVidia website. So let's try and run it and see what happens. And here we go, we got the blue screen of death while installing the graphic driver. So that's what happens every single time I'm trying to basically install the drivers on this video card. It just doesn't take the driver. Now, on many videos of video card repair I watched online, usually at this point the next stage could be to check all the rails and make sure that all the voltages are in the right place, that you don't have a short and that kind of stuff. Now, this card works, and while it's possible that maybe an unstable rail, maybe or something wrong with the voltage rail could affect the card when the driver is started, so when the card is asked to perform a bit more maybe, I find that pretty unlikely. I feel that this card has a memory issue, and without the driver that memory is not being used. The moment you go high resolution and you start using all the features of the card, that's when the card starts using that bit of memory, and that when it crashes. Now, thankfully, there's a tool which I understand is leaked from nVidia over the years, which is called MODS, which stands for Modular Diagnostic Software. Apparently, this is a very, very comprehensive diagnostic software, which I'm not going to use today, but I'm going to use the little standalone app, which is called MATS. The purpose of the MATS diagnostic package is to basically check the memory of the card, and if there is an issue and we are lucky, the software should be able to tell me exactly which one of the RAM chip, of the video RAM chip, is faulty. This card has 1.5 gigabyte of RAM, which is not much for today's standards, but it was a lot back in 2010. And we have a number of chips around the GPU, we'll check in a minute. So the next step for me would be to run MATS and see if by any chance we have some memory failure here. Now, MATS runs on Linux. I managed to find a package online. I'll put a link in the description down below. I got this from Tech Cemetery, which is a very nice channel. There's a very nice chap repairing video cards, and he was kind enough to share these MATS and MODS software with the community. So I've got this on the USB stick. Let's plug it up and run it from Linux. We are in luck here because the video card has a video output. So I can interact directly with the software and run some commands and run some tests and actually see what happens on screen, see the result on screen. But for those of you who have no video output, there is a way to configure that USB stick. So he runs the test, saves the result on a file, and then shuts down the computer. So what you're doing afterwards, you just remove the USB stick, plug into a Windows into a computer, and basically read a report.txt file, and it tells you exactly what the problem is with the card. And here we are with mods 367.38.1, which is the only version I could get to work with this video card. I'm going to issue this command, which is only testing 5 megabytes of video RAM, and format the output. Apparently 5 megabytes are enough to reveal issues, and I can always increase it later if necessary. Here we go. Here is the memory being tested. Shouldn't take long because it's only 5 megabytes. And this is the result. First of all, I noticed some garbled text up here, which is probably caused by the memory issue. Each one of these lines on the left represents one of the memory ICs on the board. There are 12 lines for 12 memory ICs. And it looks like this one is showing some writing error, if I'm saying that right. Let's run the test again to confirm, but this time using 10 megabytes of video RAM. And yes, the result points to the same IC, so this is good news, even though I guess it could also be an issue underneath the GPU where the pads connect to that specific memory IC, but let's be optimistic. Okay, so now that we know, or at least we think we know, what the problem is with this card, the next step would be to remove it from the board, disassemble it, and let's take a look at the memory configuration on the PCB itself. Well, as usual, this board needs a little bit of service, doesn't it? Right, here we are with a cleaned PCB. Now, first of all, I'd like to acknowledge the fact that Mats identified 12 memory ICs, and here we have 12 memory ICs. So that is great. It looks like the software worked when it came to recognizing the memory. The way the memory chips are organized is in, let's call them banks. Basically, you have bank A, B, C, D, and so on. And the way that Mats lists them is going to be like A0, A1, B0, B1, C0, C1, and so on. So if you look at the Mats result, it looks like we have an issue with bank F0. When you are matching the ICs on a GPU, it's very easy. It goes counterclockwise, and you have to look at the GPU where basically you can read the logo like this, and you start from bottom right. So in this case, this is bank A, this is bank B, this is bank C, and so on. Now the weird thing is that this is not A0. This is actually A1. So it's going to be A1, A0, B1, B0, C1, C0, F1, F0. And this is apparently, hopefully, the chip which is giving trouble to the whole GPU. Now this memory chip is manufactured by Samsung. It's a K4G10325FE-HC04. It's a GDDR5 memory, and it's a 1 gigabit per module. So it's 125 megabyte per module. Multiplied by 12, it's 1.5 gigabyte that we are expecting on this board. Now, obviously, I don't have replacement parts. I don't normally do GPUs, but we need to remove this chip anyways. The next step is going to be to prepare the board for BGA rework, basically. So it needs to be dried in my dry box for a few days, and also it will need to be baked for a few hours before I can actually apply heat on the board to avoid damage. I will remove the chip, and I think before I buy another one, I will try and reball it. Reballing it with leaded solder, it's not too hard. The temperatures are much lower than removing these chips, basically. So I feel I can try reball. If it works, fine. If it doesn't, I just need to order another one of these chips, replace it, and hope, basically, that the issue with the chip is under the chip and not under the GPU itself. Some time ago, I made a video about my journey through SMD and BGA rework, which has been ongoing for a number of years now. One day I'll make a part 2 to share my latest discoveries. For now, I'll add a comment to this video which hopefully can be useful to some. As I said, baking and drying PCBs you're going to set to high temperatures is very important. You can skip this step, but with greater risks. I always dry and bake everything and still I can have destructive moisture escape, also known as popcorning. The other critical thing is preheating. This is a multi-layer PCB full of copper ground planes. They act as a heatsink. Yes, you could set the hot air station to maximum, as I see sometimes done on some videos, but that's not my approach. The solder used on this GPU is lead-free. It melts at 220 degrees, so you're aiming to reach about 240 degrees for a brief moment to make sure that all the solder is molten. The goal is to preheat the whole board to about 180 degrees and then slowly heat up the IC and surrounding area to about 230-240 degrees. At that point, the IC should be free to move. Rather than using super high temperatures, my latest process involves using pretty low ones. For this pool, I used 260 degrees Celsius at the station, which is actually 260 degrees Celsius at the nozzle. I started at 190 degrees and I reached 260 degrees in about 2 minutes. At the moment, this is what appears to be the safest technique. Yes, I know this is debatable, some might disagree and say higher temperatures for shorter time is better. Well, this is my experience. Anyways, the pool worked well, even though I'm still not entirely happy with the timing. After removing the IC, I took advantage of the preheater still hot and I cleaned the PCB. First I mixed some leaded solder to the existing pads, this lowers the melting temperature. Then I wicked away the solder using good quality solder wick, which is the one recommended by Adrian of Adrian's Digital Basement. It's truly good quality, the name is below in the description. Finally, a good clean with isopropyl alcohol, but not before the board has cooled down a bit. I moved the memory IC onto a metal surface and that was a mistake. It cooled down instantly, not what an IC would like. Anyways, I cleaned it, as with the PCB. When inspecting the outcome, I was happy to see that the PCB on the video card was completely undamaged. However, on the memory IC, I noticed some dull looking pads. I guess that could be the very cause of the failure. I read online it's a manufacturing issue involving phosphor. Some YouTubers suggest to scrape those dull pads with a soldering iron and that would guarantee a better solder adhesion. I'm not sure what's wrong with those pads, as they do take solder when I melt some on them, but they become dull when cooled down. Anyways, I learned something new today. When cleaning pads, never insist with the soldering iron for too long or the IC will cook. This area is brownish and it doesn't look right. I don't feel I want to attempt a reball on this IC. This is an old GPU, I ordered 4 RAM chips for £6, so I guess I can wait a bit and try with a brand new IC. Now, while I'm waiting for parts, I understand it might be possible to run mats and mods, even without a memory chip. What I'd like to try is to run it and confirm that now the same module is showing errors and nothing else, just to make sure I've removed the right memory module. And we do have a video output, which is great. 1, because I wasn't expecting it, and 2, because the board still works. So let's put into mats as before, let's run it, and let's confirm that we have exactly the same error message here. So the screen is becoming very garbled, it's very difficult to read, but you can see that now the very same chip is showing even more error messages. Well, obviously the chip is not there, and that is confirming me, hopefully, that I removed the right one. So at this point I would say, let's wait for the spare part, and then we replace it, and finger crossed, hopefully we can fix that. And the spare memory modules have arrived. I purchased them brand new and they arrived sealed in this plastic tape, so hopefully they're actually brand new. I purchased 4 of them, 2 have been baking here with the board. Now, as you can see, the ICs come with solder balls attached. Now, this is a 2010 product, so these are going to be lead-free solder balls. I really don't want to use that lead-free solder. It melts at 220 degrees compared to 180 degrees of the leaded solder. So I'm going to remove those solder balls and reball it, and that should make the process of reattaching the IC to the board much simpler. To reball the ICs, I've purchased these 0.45 solder balls from Best. I hope they are from Best. I also purchased a stencil, like a dedicated stencil for DDR5 ICs. Now, to be honest, I kind of regret getting it, because I think you can totally use the generic one that you get with your reballing jig. Obviously, you need to be a bit more careful. You can't just pour solder balls on top of it, because half of them will just fall underneath. But if you're not doing this on a regular basis, like every day, this is totally fine. Don't worry about buying this one. And again, it just takes a few more minutes and you just need to be a bit more careful. Now, for the reballing process, I will point you to my previous reballing video that has all the details. What I can do during the reballing process, I can maybe add some comments to explain how the reballing procedure has evolved over the past few months. Not that I do that very often, to be honest, but I might have some comments on things I'm doing slightly different, or at least things I'd like to point out. Let's start with removing the solder balls from the ICs, and then we'll try and attach one of those ICs onto the board, and let's hope for the best. As I said, you'll find a link of my reballing video in the description that will explain all the process in details. I follow the same process here. First, I melted the lead-free solder balls from the IC, then I wicked away all the remaining solder. Finally, I gave it a good clean. I feel that my decision not to try and reball the existing memory IC for a test was good. All pads on this new IC look very shiny, which is good. At this point, I applied a little amount of flux on the IC. This serves 2 purposes. First, without it, the solder balls would roll away. Second, without it, the solder balls wouldn't bond to the pads. Now, I'm aware that the quantity of flux applied at this stage is critical. Too little and the solder balls would roll away. Too much and the solder balls would float on it when it liquefies, resulting in a big mess. However, I ended up with a weird situation here. After applying all the solder balls, I moved the IC to the preheater and I preheated it to about 160 degrees. Then I thought it would be pretty easy to just reach the required 180 degrees for the leaded solder to melt, but to my surprise, the solder didn't look like it was melting, and the shape of the solder balls on the IC was telling me that the bonding was not good. The solution, after much struggling, was to add some flux and flow the solder balls again. That immediately aligned all those little spheres into position. Now, I'm aware that this is a required step, but in my previous attempts, the solder balls would melt and align, but just remain a bit dull, requiring a reflow with added flux to make them shiny. So maybe on this occasion I should have applied a little more flux, or maybe the quality of the solder balls I purchased is not great. Anyways, the outcome was okay, even though I insisted a bit too much with the hot air, which was still running at 260°C maximum. Now it's just a matter of reattaching the IC to the video card. After making sure the PCB is perfectly clean, I applied a small amount of flux on the surface. Then I carefully positioned the memory IC, which is critical for the success of the operation. At this point, the card is preheated to 150 degrees Celsius, and finally I used hot air at 260 degrees to slowly reach 190-200 degrees required for the solder balls to melt. If I'm speeding up the footage, you can clearly see the moment where the solder melts and the IC drops. Finally, I let the card to cool down and I gave it a good clean with isopropyl. Right, it's done, so I'll give it a clean, I'll install the heatsink, fit it into a motherboard, and we'll test it and see if that worked. Right, okay, so as before, I only have the main heatsink attached, and I've also attached the fan just in case it's checking for the speed or something. Well, let's power it up. First of all, let's see if it still works, and secondly, let's see if the RAM error has gone. Okay, in 3, 2, 1, go. And there is a picture, that's good. Right, moment of truth. Will it work? Let's give it a go. It's working, look at that! Well, there's no error messages at least. I still have some kind of corrupted text here on the left, but no errors. Wow. I was totally not expecting that. So I would say the next step would be to get into Windows and see if the driver works. Okay, well, is it just my impression or there's a higher resolution than usual here? Because I think this wasn't going any further than 600 by 480. 1920 by 1200. I never had this resolution on this monitor with this video card. So let's see if Windows has installed the driver. Yay! nVidia GeForce GTX 480, the driver is on. Right, just to confirm it, let's actually install the driver from scratch and see if that works. Well, that's something new. The driver failed to install, but we don't have a blue screen. So I have a feeling this is a Windows issue, to be honest. But I never had this before. I have nVidia cards myself. I never had this kind of error message, so I really don't know what that could be. So let me fiddle with this Windows installation and see what happens. Windows 10 refused to install the proper nVidia drivers. The card would default to a generic display device, and then Windows would install the generic Microsoft driver on it, but nothing more. I thought it was some unresolved memory errors, so I ran maths for hours, letting it check the whole VRAM, but that never showed any issues. I thought that maybe under Windows the video RAM was being stressed a bit more, so I found this VRAM memory tester called memtest G80, but that did not show issues either after many passes. I did uninstall the driver using DDU, display driver uninstaller, but that did not improve things. I was so disappointed until I decided to try a Windows 7 installation. After all, the GTX 480 was released in 2010, which is when Windows 10 was not around yet and Windows 7 was still a thing. And that worked! Finally, I tried another Windows 10 installation I had laying around, and that worked as well. So I'm not sure what happened, but it was that specific Windows 10 installation. So let's run the stress tests. I used a number of software to stress this card, which by the way the online community used to call it the space heater, as it's infamous for running very hot. Unigine Heaven benchmark ran perfectly fine, and it ended with a score of 486 and an average FPS of 19.3 with all the settings maxed out. Then I ran some of the tests including the MSI Combustor application. As you can see with this test, the card runs pretty hot at 81 degrees Celsius with the default fan settings. I found that undervolting the GPU and changing the fan profile lowered the temperatures quite a bit. That said, the fan is pretty noisy unfortunately. Out of curiosity, I checked the power drawn at the 12-volt line when using the most power-hungry stress available, which turned out to be the donut. That ended up drawing 20 amps, which is 240 watts out of the 12-volt line, and this is just for the GPU. I did not want to run those tests for too long, as back in 2012 my own GTX 460 used to badly crash when running them for a while, requiring some power off time before it would come back to life. That being said, all the tests ran perfectly fine with no issues. Well, the video card works. I've been playing Dirt 2 and it worked totally fine, absolutely flawlessly. This card is like having an oven on your motherboard. It's absolutely insane that it runs at these silly temperatures. It's getting really noisy. It can be mitigated a bit if you're running some software like Afterburner. You can undervolt it a bit, and you can use a different fan profile, because the default fan profile, it's very conservative as it prioritizes the noise of the card, as you might expect. But this card is absolutely worthless. In 2023, this card is lower than I think a 1050 Ti, which can be had for very little, and it stays stone cold basically all the time. So I'm not sure what's gonna happen to this video card, but I don't care. It was just an exercise for me. This was my first BGA replacement chip that I've done on camera, successful replacement. So I'm really happy. I'm not sure what happened with that Windows 10 installation, to be honest, but clearly there was something wrong with it. But anyways, that's been discontinued for so many years. Drivers are not developed anymore. So honestly, I don't care. It works. Memory tests are working, and it works fine on this Windows installation. So from my point of view, the repair is a success. If I have a little bit of time and I feel in the right mood at some point, I'd like to try and have a look at this heatsink. I've noticed the heatsink is far from being flat, and I'd like to lap it and try to make it a bit better. So watch this space, I might do it at some point. For now, I think this is it. So I hope you enjoyed this video, and if you did, I would really appreciate if you could hit the like button down below and consider subscribe to this channel if you like what I'm doing here. For now, thanks for watching, I wish you a great day, and I hope to see you again soon here on this channel for my next videos. Thank you very much, and goodbye. Bye.